So now to focus on some of like our big section, we are going to talk about percentages. And so in the world of percentages, we also talked about absolute change, but then our major percentages we focused on were percent of and then percent change. And so how do we calculate the percent of? And when do we? The great news about when do we is it traditionally will say in the problem, you know, blank is what percent of something else, or figure out what percent this is of another number. And so you're seeing that actual phrase percent of. And we don't always get that lucky in that we have like the exact keywords we want, but here we often do. And so we take our compared value, we divide it by the reference value, then it's a decimal percent, and then we multiply it by 100. We can also calculate percent of from not just the compared and the reference values, but from percent changes. And so as long as we have a consistent reference value, then if we knew the percent less, we could find the percent of by taking 100% and subtracting the percent less. Or if it's not the percent less, if it's the percent more, we can take that 100% and add the percent more, right? So if it's like 10% less than A, that means it's 90% of A, right? Like if I lost that. Or if you get 50% more than someone else, you have 150% of what they had. Sometimes we have percent of in the problem, like literally, like it's not a problem of finding percent of, but we have percent of, and what we're really needing here is a value. And if that happens, what we're going to do is we're going to write the statement. So we need a statement that has the compared and the reference value, though one is usually unknown and one's known, and the percent, and we're going to write it as an equation that then we can solve. Very basic equation. So what we're really looking for is a statement like A is whatever percent of C. And so how does that look in an equation? Well, A is, so is becomes equals. Our percent, of course, needs to be a decimal, so you can do your decimal point moves 2 places. You can do your times 100. Now here, of is an operation because it's smack dab in the middle of an equation. So going back to 2A, we learned that that was times, and C. So here I could solve for A by multiplying this, or if I need to solve for C, I could use a little bit of multiplication. So let's look at 2 quick examples of that. So what if we had like 10 is 50% of what? If I wanted to solve for this, I have the percent of, I need a value, so I stick this into an equation. So 10 equals 50% is got to be a decimal. Of means times. What means I don't know. Solve for both, or solve by doing the same thing to both sides, and you get x is 20. Or another example of that might be something like, what is 40% of 60? Now, they won't always come right out and say 60. They might be like, there's 60 students in this class. What is 40% of the number of students in this class? But you can get it into this statement. And so then our unknown is 40%. Let's change it to a decimal of 60. And here I can just multiply the two. 10% of 60 is 6. So 40% is 24. Now, a very important concept in this section is understanding the referenced value. So up to this point, percentages you've dealt with may have been very basic percentages, and there's always like a total that goes in the bottom. But percentages are powerful because I can use a lot of different ones, but if I'm going to compare them, they have to have the same reference value. So what is the reference value? So this is what's going to be like the bottom of my fraction, whether it's percent of or percent change. And there's kind of 2 scenarios. If we've got an older value and a newer value, If that's the case, the reference is the older value. So if you're trying to calculate this percent change from an old number to a new number, or the percent of, generally the older value is what we're going to reference because that's kind of like the standard, like the set in stone. But more often than not, we're going to need to look for the reference value. So the reference value, if it's not the older value, it is what is referenced by the percent statement. So if this is in like standard grammar, you'll see things like whatever, whatever, whatever is a certain percent. And I'm going to use of because that's where they're all, what we're doing. But this could say percent greater than, percent less than, percent whatever. Oh, it's not A again, a different one. Let's go with B. And so this percent statement, in this case it's of, is referencing B. That makes B the referenced value. So let's look at that. If we had a price in 2000 was $4 and we found out the price in 2010 was $6 and we weren't really given any other information here and we were asked to work with percentages, which one of these would we assume is the reference value? The older one, notice not the smaller one, right? Because prices could decrease on certain things. Lots of things decrease over time. But here, because it's from the earlier year, it's the reference value. Okay, how about in one of our, I think it's a test review example. The price for, like, let's say Walmart stock is blank percent of that price for Apple. Okay, so this is not old and new. This is, in the same time frame. I'm comparing these two. So what are we going to pick for our reference value here? We are going to pick what is being referenced by the percent of statement. So the percent of here is referencing the price of Apple. So here our reference is going to be Apple's price. Someone asked me, usually is it always what's at the end? And you have to be careful of that because, especially in questions, we change the order, but it's what goes with the percent of, percent more than, that kind of statement. The other big part in this was change. And so we looked at multiple types of change. We had kind of basic change, which was absolute change. And we said that this is the actual change. Like all we need to do here is do some subtracting. And we have this formula where we take the observed or the compared value and we subtract the reference value. What's important to remember about this? Because we're doing subtraction, you can take almost any unit, subtract that unit, and get that unit. So a lot of the times here, units for absolute value will be whatever you started with. What's the exception? If what we're working with are two scenarios that are percentages, if I take a percent and I subtract a percent, we're actually going to report that as a value of percentage points. So don't forget that important thing right there. Absolute change of percentage points, of percents, is going to be a percentage point. Our other type of change is relative change. Now, the trouble with relative change is it is so applicable. The great thing about relative change is it is so applicable. So you might be calculating relative change and the problem might say find the relative change. But you also might be asked to find the percent change or the percent difference, the percent more than, and in the same way, the percent less than. You might be asked to find the percent increase. You might be asked to find the percent decrease. You might be asked to find the percent shorter than or the percent longer than. So for all of these, someone usually says, how am I supposed to remember all those? The great thing is all of these are changes, right? Like a changing, more than, less than, increase, decrease, shorter than, longer than, they all are describing the change. So that's at least all related. We do have a beautiful formula where we take the relative change and we take the absolute change that we've already worked with and we divide by the reference value and we multiply by 100%. Multiply by 100 to get our percent. And a great thing about relative change is the units are percent. So you can take a whole bunch of stuff, and then if you divide it by that reference value, multiply it by 100, it's now our percent. So absolute change is in the given units or percentage points if I'm working with percents, but relative change is in the percents. Ready to work a few? City A's population is 28% less than City B's population, so City A's population is blank percent of City B's. So notice both of these percent statements are referencing City B, so they have the same reference value. And so if we're saying, that this is City B, this big pie chart, this is 100%, we have to knock out 28% of that for this to be A. So A is what's left here without this 28%. Well, if the total is 100%, I've knocked out 28%. That leaves me with 72%. Similarly here, this next one both references the same city. In this case, they're referencing C. And so this is C's population. And City A is not only this circle, but also a little bit more. And so notice this would also be C's. It's the same size, but we don't need all of that. We need about 28% more. So A is all of C and 28% more. So that's 100% plus 28%, so 128%. So we are asked to calculate in 11. Apple's 20 and 15 revenue was $233 million. Walmart's in that same year was $482 million. Apple's revenue was blank percent of Walmart's in 2015. So hopefully the first thing you caught there was we're going to calculate percents. The next thing we should catch is that it's a percent of. And so percent of is the percent of formula. So we're going to put the compared value over the reference value, and then we're going to multiply by 100. So here, don't really read all this compared to and all that. That's going to make you confused. Look for the percent of statement and look to see what percent of is referencing. So percent of here is referencing Walmart. So this 482 is my reference. This 230 is my compared. 233 over 42. 482, I don't know why I'm losing numbers in there, times 100. And I get 48.34. So I'm just going to call that 48.3. Now I'm jumping down to 17 because I want you to see something. This reads almost exactly the same. We got 233, we got 482, we have the statement with percent, but now we're doing percent larger than Apple's. So we're changing two things here. Now my reference value is 233. Now my compared value is 282. And am I trying to calculate a percent of? Nope, that's larger than. That's a change word. So this is a calculation using relative change. So it's compared minus referenced over referenced times 100 because I want the change. So 42 minus 233 over 233 times 100. Oops. Oh, this is not going in my calculator well. So remember, you can use that N over D button. That's a really helpful one in your multi-view. You can also do this in multiple steps. So in the end, the difference in these two is a little more than 233, and so it's actually 106.9% more than Apple's in that particular year. And this one reads, again, very similarly. Apple has, you have two values in here. You've got a 233 million and a 260 million, and you're asked to find, in this case, the absolute change and the relative change. But here, you don't have that statement like the percent more than something something, because you don't need it to be referenced, because you have an old number and you have a new number. I know, like, it's 1 year newer, but that's all that matters. And so here you can jump straight into your absolute and relative change formulas with referencing the number from the previous year. What we're going to practice here in this similar statement is 21. It says in 1950, 75.5% of manufactured cars were made in the U.S. By 2015, only 13.3% of them were. We're going to describe the absolute and relative change using the correct unit. So absolute change says let's take compared, let's subtract reference. And so for us, that means we've got compared is our newer number, so that makes compared 13.3, kind of weird, I'm not used to that being smaller, and reference being 75.7. So I'm going to do 13.3%, I'm going to subtract 75.5%, I think I said 7 a second ago, sorry, and that's going to give me negative 62.2. And so negative shows that this is a decreasing value, and that is what the numbers say, so that's encouraging. And then we usually just write whatever unit we've subtracted by unit, but we don't actually have units, we have percents. So this has got to be percentage points. Then we're going to calculate the relative change is the next thing it tells us to do. So we're going to take the compared minus the reference. We're going to divide it by the reference and multiply by 100. So this is still going to be 13.3 minus 75.5. divided by 75.5, because we do need to make sure that reference number is in the bottom. So we're again going to get a negative, which makes sense. This is going down, negative 82.4. And this is a percent. If I have divided by the reference and multiplied by 100, it is now a percent. So notice that we did a lot of multiplying by 100 here, not for absolute change, but for all the different relative changes, because those need to be a percent.